All right, 10.1 practice. Name the circle. There's really not much to that one. There's only one choice here, and that is you put a circle with a dot in it and C for the center right there. Name two radii. So the radius goes from the center to the outside. So we have CD. Again, you could also call that DC, doesn't matter in the order. Or you could go with AC or CA, doesn't matter. You can put the center first, center second, doesn't matter. But notice it is a line segment, so we don't put arrows. Name two chords. So one chord would be right here, BH. And as I said in class, technically, the diameter is a chord. Okay, just like a square is a rectangle, but we use a more specific term usually. A diameter is a chord, but usually we'll just refer to it as a diameter. Which brings us to number 8. The diameter is AD. Notice again, these are all segments. Name the secant. Okay, that's the one that's going to be through. It's like a chord that keeps going. So that is going to be GH. I'm sorry, my bad. HK. Or GK, it doesn't matter. So since this is G, and this is H, and this is K, and technically that's B, you could use any 4 of those letters, as long as you put the arrows over it. Most people use the furthest out letters, like this, but make sure you put the arrows. But again, you could put BH, that's a K. But it's very important if you put BH, because remember that's up here, you have to put the arrows over it to show that it keeps going. But you could do BK, HK, whatever, as long as you show the arrows. This is probably the most common one because you would pick the letters that are outside the circle, but it's up to you. And 10, name a tangent. That's the one that's outside. So again, you could use any one of those 3 letters. Most people use the outside letters, GE, but GF would be appropriate as long as you put these arrows over it. And the point of tangency is that F, where it touches the circle. Okay, how many tangents and draw them? Okay, so this is not going to be perfect, but you could have a tangent out here, a tangent out here, and you could have that X tangent like this. I do my best there. So that means there's 4. Okay, 2 interior and 2 exterior. All right. With this one, since one is sitting inside the other one, there's no way to do it. It's none. For this one, we can have 2, and they're both exterior. And for this one, since they're touching at that point of tangency, we could have 1, and it's exterior. It's outside the circle. 15 through 18, tell whether the common tangent is internal or external. Okay, kind of just like it looks. That's outside. Now, this one's tricky because you think, oh, it's in between the circles, but it is outside each circle. It's in between the circles. So this one is internal because in between the circles, and this one is outside the circles. Okay. Tell whether it's a tangent. So if it's a tangent, this will be a right angle. And on here, this will be a right angle. Okay? So in that case, that makes this C. That's the most important one. So 3 squared plus 4 squared equals, that's a question mark right now, 5 squared. But if we do that, we get 9 plus 16, which is 25, equals 25. Check. So that's a yes. On 21, we're going to do 48 squared plus, be careful here, I almost did it. 20 is the radius, so this is also 20. So this entire line here is 40 equals 60 squared. And again, this is a question mark. If you want to, you can also just put an empty box because we don't know if it is. Your choice, right? When we do that, we get 3904 and 3600, which is clearly not equal, so the answer is no. BA is not tangent to that circle. Now 23 is kind of a tricky one because some people will go, obviously that's C, but C is not 16. It's R plus 16. That is the entire hypotenuse. So this is A, so we'll call it R squared, plus 24 squared equals R plus 16 squared. So we have R squared plus 576 equals. Now this one's tricky. Now if you need to, you can come off to the side and, you know, FOIL this. First times first, outer, inner, last. Okay, if you need to do that. Or if you remember the shortcut from Algebra 1, you can just square the first term, square the last term, and then multiply and double the outside and inside. So 32R. Now, it's not as scary as it looks because when you try to get rid of R squared, you get rid of it on both sides. So when you subtract R squared, it cancels. Doesn't matter which way you're moving it. I'm also going to move the 256 over, which will give me 320 equals 32R. Then when I divide, I get R equals 10. And that's what we were trying to find. It was find the radius. So this is 10 and this is 10. And the beauty is you could actually now check and plug that in. You could do, 10 squared here, and this would be 26 squared when you plug it in and check the math. Okay. Similar idea on 25. We have R squared plus 14 squared equals R plus 7 squared. So that's R squared plus 196 equals R squared, R 7 squared here, and then multiply and double, 14R. Again, the R squares just disappear when I do that. I want to minus 49. That gives me 147 equals 14R. And I divide by 14, and I find out that it is 10.5. And then my last two. Remember, when I have a point out here and I draw tangent lines, they are simply equal to each other. So I just do some basic algebra. 2x plus 7 equals 5x minus 8. I'm going to subtract 2x, so I like to keep my x's positive, which means I'm going to add 8 here to move that over. That gives me 15 equals 3x. I divide by 3, and I get x is 5. Same thing here. 2x squared plus 4 equals 22. I'm going to subtract 4. 2x squared equals 18. Divide by 2. And I just square root both sides. And that gives me plus or minus 3. And it's okay to get a negative here because in this case, negative 3 squared is 9 times 2 plus 4 is 22. Now, if we ended up with that being just the measurement of a side, we'd have to throw out the negative number because you can't have a negative measurement, but you can have a negative x value at times. And that's it.